On today's Build Show, I'm in Portland, Oregon, and we're talking about fluid applied weather barriers. I'm in Portland, Oregon for a conference, and I called my friends at Prosoco and said, hey, would you give me a tour of the labs? So I'm here with Stace Grund. Stace, thanks for joining me. And I've also got Jake, who's going to be doing a side demonstration while we talk. So Jake, why don't you get started on that, and I'll come back to you in a minute. Stace, you got a really interesting background and a really interesting story. Tell me about your company, how old you guys are, and kind of the genesis to this Prosoco product that we're going to be talking about today.
Yeah, the company was founded in Seattle by my great-great-grandfather back in 1898. So this year we made it 119 years. Commercial painting contractor started out in 91. We started another company called Tattly building envelope repairs and maintenance to buildings. As that progressed through the years, kind of mid to the late 90s, we were putting buildings back together that were failed, some 3, 4, 5 years old. A lot of it multifamily, significantly large structures and large repair contracts. And the details at the time, as we were pulling them apart and fixing them, we were asked to put them back, not a whole lot different, and we got quite concerned about how that was going to work for us from a liability standpoint. So we developed our first test chamber in my partner's backyard in about 98, 99, and we started testing windows, walls, different products, because we just really wanted to know. We didn't want a lawsuit against us from a building envelope failure. So that progressed. We worked with a couple of large manufacturers here in the U.S. looking at a liquid applied process. Ultimately, it didn't work out with us, so in 2004, 2005, we decided, a couple of goofballs in Seattle, we went and hired a chemist and said, here's what we want from a contractor's perspective. So it was really kind of from an applicator and risk perspective from the contractor on up. Came up with this list of 29 items. We called it the wish list, and within about 3 or 4 months, he had a product for us. And we started using it on our own jobs, and in about 2005-06, we started a separate company, applied for the patent. So we achieved the patent application, or got the patent on that process for a method and use patent on the products, and took the product to market.
That is what an amazing story, Stace. You know, as a contractor, I love that you guys are a family-owned company. You're still owned by individuals. There's not a corporation and Wall Street telling you what to do. And what decisions you've made and the testing, you've come up with some pretty impressive products. Now, we did a video not that long ago with these guys out on the job site talking about all the application processes. But what I wanted to talk about with you today, Stace, is what kind of separates this generation of new products that you've developed, that now there's several kind of Me Too's out there in the marketplace, from what we're normally seeing out in the residential field?
Right. It's really somewhat of a paradigm shift going to a liquid applied process from a sheet good. Many of those are good products and have, in certain applications, they do very well. But for us, primarily starting out at window and door penetration, flashing for that, we just felt that the liquid was the right way to go. It fits every opening every time. Before that, we were doing a lot of metals, stainless and sheet metal flashing, and we were concerned about being a thermal conductor and then just measuring, mismeasuring, ordering, installing, and the labor costs. So we really wanted to go to the liquid applied process. So it's for us, we've been doing it now for 12, 13 years, 14 years, but it's still relatively new to the industry.
Yeah, and tell me about that. You know, I've had, since we posted that video a couple of weeks ago kind of talking about the process, I've had several people ping me and say, you know, how long is this going to last? Is this going to be on the building 100 years from now? Can you speak to that a little bit?
Yeah, we had that question when we were getting started out, because really we were bringing a whole new way of waterproofing the building envelope to architects and engineers. And that's a standard question, you know, how do I know that it's going to last? So we did one of our first projects was in 2005, and in 2010 and 2015 we got approval from the Homeowners Association. We disassembled the exterior cladding, had the same building envelope consultant take a look at it, and gave us a look at 5 years and 10 years, and there was no difference in the products. They were performing exactly the same way as when we installed them in 2005.
All right, Jake, what'd you do here, my man?
So I took a cardboard box, coated the inside of it with the fast flash membrane, just to show how obviously you start with cardboard that's not waterproof, and you can make something waterproof in just a matter of seconds.
Let's fill up this jug and see how this thing does. All right, so we took a standard cardboard box. In fact, let's wet a little bit of this cardboard over here that you pulled out of there, Jake, too, just to show everybody that it is regular cardboard. We're filling up with, what, 1.5 to 2-inch head of water right there?
Yep.
This is their fast flash membrane, which they're using for flashing of windows. And let's just wet that down, too, just so we can show people. That's just regular old cardboard. It is soaking it right up. All right, so here's an interesting test that you told me we could try. What if we take some screws or a couple nails, Jake? What's this going to do to it?
Let's find out. So running a couple screws underneath the water line here.
Yeah, that's pretty awesome. Can we poke a nail through there too?
Yeah, let's do that.
Let's try that. That is awesome. Can you pick that box up too? How about that? That is pretty impressive. We're going to let that sit for a while, and we'll come back here and look at this. But so far, so good. Holding water. Very impressive. Waterproof from the start, too.
Absolutely.
All right, next, Stace, I wanted to talk to you about this test rig back here. So let's go back here and have a look. Hey, Stace, tell me about this test rig. This thing is a beast.
It's a test chamber that we designed and then constructed ourselves to test window and wall systems for air penetration, water, and structural, and we can go up to a simulated 200-mile-an-hour wind-driven rain.
Ooh, that's pretty serious. And this window that's installed here, this is not a new window. This looks like it's maybe 20 years old. What's the story here?
Yeah, it's in Seattle. My company, we do a lot of repair and replacement of existing building envelopes. We were approached by the Homeowners Association. They were looking at a fairly expensive window replacement. They didn't have the funding for that, about 1.2, 1.3. So we took the window out, brought it to the chamber, developed an in-place repair by the use of the chamber that we're going to go install for approximately $400,000. So about a third of the cost. Should extend the life by 10 to 15 years, allow them to do a longer reserve analysis or longer reserve funding.
That's pretty cool. I bet that penthouse is not loving their current windows that are leaking air and water. This is going to be a nice change for them. And, of course, it's using your Prosoco R-Guard system, which let me point out here, this is a detail that I love that's a paradigm shift. You know, most people think about just waterproofing the sill. In this case, we've used that R-Guard all the way out here. This is their fast flash, the dark red one, not just on the sill, but on the jambs and on the head. So it's coming all the way in to the inside face of the stud. And then after that fast flash is done, they've got the air dam right here made out of that same chemistry membrane, back caulking everything in place. So now this window, if it does leak, it's going to leak to the outside, and it's going to resist both water and air penetration. So you can take a run-of-the-mill window and make sure that that window is really going to be airtight and waterproof for the life of the building. Very impressive. Hey, they've got a really cool display over here that I want to show you, and we'll end with that. Let's walk over to the other side here. Hey, Stace, what's up with the goldfish pond you got going in here?
Well, as a pioneer of the product, like we talked about before, oftentimes we are asked, the question, is it truly waterproof on the sill where water might be horizontal and sitting there? So we installed a window exactly like you would in the field, turned it horizontal, filled it with 3 to 4 inches of water for head pressure, shimmed it out just like you would, and it's been sitting here, both of these specimens, for 3 years with no leaks.
That's pretty cool. So these shims are letting water into the sill, and then the back dam is your product as well on the back side. Is this the same cardboard test, or was it what we saw before?
Yeah, it is. It was actually a demonstration we did at a trade show. It was 5 years ago, and so it's the same water that's sitting in the boxes on the floor of our shop, and it hasn't leaked.
Man, 5 years later, this cardboard's still looking good. Super fun day today in Portland with the guys from Prosoco. For more information, visit their website at prosoco.com. Otherwise, be sure to follow me on Instagram or Twitter. We'll see you next time on The Build Show.